Hi everybody, I just wanted to make a quick video on some of the questions from the quiz review for today, especially if you're at home right now and you haven't used a TI-84 to find probability or find areas under the curve, or if you haven't used the app Calculate 84 to find areas. So I'm going to go over one of each type of question from the practice quiz. So here's a quiz review that we're doing in class today. So if you're not, you can do it at home. Now, first thing to notice on questions 1 and 2, you want to answer them based on empirical rule. So empirical rule, I'll go back to the guided notes when we talked about empirical rule, whether you're in class or not. Empirical rule and the guided notes, I gave you these two pictures, and what the gist of these two pictures was that 68% of value, if something's normally distributed, anything that's normally distributed, 68% of values will fall within one standard deviation of the mean. 95% of values will fall within 2 standard deviations, and 99.7% of values will fall within 3 standard deviations of the mean. This is just like a rule of thumb if you don't have a calculator. What I did with that normal curve for you is I took empirical rule and I broke it down even further in the guided notes. So this second picture is really what's going to be useful to you. And in a quiz or a test, I'd let you use this. I'll probably put it on the board for the quiz tomorrow. If you're at home because you're virtual, you can get this out. So let me go back to the practice quiz. So you're supposed to use empirical rule for questions 1 and 2. So let's just do question 1. The mean life of a tire is 30,000 kilometers. The standard deviation is 2,000 kilometers. Well, first of all, I'm given this blank curve, so I'm going to label it. And we know from class, or if you watch the video PowerPoint on these normal distributions, the mean will always go in the center. So here is the 30,000 kilometers. I'm just going to put the zeros below if you don't mind for space. And then every standard deviation above, I'm going to add 2,000 because they tell me the standard deviation is 2,000. So this would be a tire with 32,000 miles or kilometers. And then 2 more thousand makes this 34,000 and 36,000. And then we'll do the same thing going the other way, but we'll subtract that standard deviation. So this will be 28,000 kilometers. I apologize for my writing. I'm using my fingertips on the keyboard. This will be 26,000. And then 24,000. So empirical rule in general for this curve, 68% of tires fall within 1 standard deviation of the mean. So 68% fall between 28,000 and 32,000 kilometers. And that happens to be the answer to the first question here. And this is just straight up empirical rule from the notes. Now the second part of empirical rule, the 95% of tires will fall within 2 standard deviations. So here's my mean. If I go down 2 standard deviations, I'm here at 26,000. If I go up 2 standard deviations, I'm there at 34. So that's from 26,000 to 34,000 kilometers. That's a 3 right there. What percent of tires have a lifetime that exceeds 26,000 kilometers? All right, I had to rewind a little bit and start recording again. So we got to part C here, and I want to mention that the whole area of the curve is 100%. And based on this empirical rule, I know 95% is from 2 standard deviations from the mean. So this here in the middle is 95%. And if the whole area is 100, that means there's 5% left over. But I only want this little guy in addition to the 95. So half of 5 gives me 2.5. So the percent there is 97.5%. Now you could also use the guided notes. You could go to the guided notes and use this breakdown curve, and you could have added all those percents, or you could have subtracted these two from 100. Either way, I just kind of used common sense there. And then part D, if a company purchased 2,000 tires, how many tires would you expect to last more than 28,000 kilometers? So let's use that same rationale I just did. I'm going to switch colors. So 28,000 is right here. So I want more than, so all this. I'm going to use that same rationale I did before. If I know this from 28 to 32. I know this middle orange section is 68%. Now that tells me if the whole thing's 100, well, 32% is left over on either side. So that means I need 16% right here. So again, 100% is the entire area of the curve. So if you subtract 68 from 100, you get 32, but I have two tails. So half of it gives me 16 in this one tail. So the total area, if I do 16 and 68, the whole area of this orange tail is 84%. But that doesn't answer the question. So now I need to find not 84, but I want 84% of 2,000 tires. So to do that, I take those 2,000 tires and I multiply it by not 84, but 0.84, just like you'd calculate a tip at a restaurant. And let me see what that gives me. I get 1,680. So 1,680 tires about would last more than 28,000 kilometers. So questions 1 and 2 involve empirical rule. So you want to use these three numbers. You can manipulate it. You can go back to your guided notes and use the breakdown curve that I gave you. Really whatever your fancy is. Let's do a couple of the next ones. So starting at question 3 in the quiz review or the practice quiz, it says now use normal CDF or inverse normal. So you need a calculator. And if you're at home, you don't have my Inspires, so you'd either need a TI-84, which I'm going to have on my screen, or the app called Calculate 84. That's a free app on iPhone, I guess on a Droid as well. Calculate 84. It will do everything we need it to. It'll look a little bit different, and I really can't bring it up on my screen, but I'll try to explain the small difference in how it looks. I'm just going to pick one question that has both of those in it. Let me go down here to number 7. So number 7 is going to have both functions of the calculator. So here, a grading scale is set up for 1,000 students' test scores. It is assumed the scores are normal. So as soon as you see that word normal, I go ahead and I sketch a normal curve. And they tell me the mean is 75. So I go ahead and I label that in the middle. And I also usually make a note of the standard deviation. They tell me here is 15. So this curve is going to tell me everything I need to know or anything I need to answer. I'm going to answer based on this picture. If 60 is the lowest passing score, so let's find 60 on my curve. Well, if 75 here is here, 60 is somewhere down here. So I label it 60. How many students are expected to pass? So you're going to pass with a 60 or better. So I'm going to shade above 60. So all of these students, 60 or better, are going to pass this test. So first I need to find, well, what is this shaded area? What percent of the curve is this shaded area? And then I'm going to use that percent in 1,000 to figure out how many kids are going to pass. So in the TI-84, if you have the app, to find normal CDF, you go to second VARS. So right here under the keypad is VARS. So second VARS. And then we're going to pick option 2, normal CDF. Now, if you have the app, it does not show up like this. It shows up, I think it gives you an open parenthesis, and then it gives you these same things. It says lower, comma, upper, comma, mu, comma, sigma. So you're going to fill it in based on this picture, but I guess horizontally with commas. And the comma key is right here above 7 on the app. And I'll show you on my screen. It'll look like my screen when I press enter. All right, well, lower, regardless of how you're typing it in the calculator, lower bound, it means how far left is your shading. So if I go back to my picture over here, the left part of my shading is 60. Upper bound is how far right. Well, this shade's technically forever. So we talked about in class, I make the joke of George Sink. So dial all 9s. If you're shading forever, all 9s. Just put a bunch of 9s in there. The mean we were told was 75, and the standard deviation was 15. And when I do paste, this is what it looks like on the app. So if you're using the app, you would just use commas and type in 60, I think the same order, 60, comma, George Sink, and then comma 75, comma 15. So the percent, oh, it's close to 84%. So I get 0.841 or 84.1%. But of 1,000 students means I multiply that by 1,000. And this is easy without a calculator. You get 841. So 841 of those 1,000 students are expected to pass. All right, the other thing you'll use in the calculator, you use inverse normal when you're given a percent. So in part B, I have the same curve, I have the same picture to start, right? My mean 75 in the middle, standard deviation still 15, I don't have a lot of space here. I want to know the top 5%. What score gives me the top 5%? So now I want to know, well, what is this value? I'm just going to call it X. What is that? That this area is 0.05, right? 5% is 0.05. So what area, what score gives me that top 5%? So to do it in the calculator now, I use inverse normal. And in class, and if you look at the guided notes, inverse normal is great, but unfortunately inverse normal only understands left tails. So to use inverse normal, I'm going to have to find this area. Well, no big deal. If this area is 0.05 or 5%, that means the rest of the curve is 0.95 or 95%, right? We know any density curve has an area of 1 or 100%. So whatever this is on the right, the left side is just the what else you need to get to 1 or to 100%. So I'm going to go to the calculator. Similar steps, I go second VAERS, but this time pick inverse normal. So whenever you're working backwards, meaning you're given the percent and you're finding the score, use inverse normal. And the area is the left area, so that's 0.95. The mean is 75 and the standard deviation is 15. Again, if you're using the app, you just put commas. You put 0.95, comma, 75, comma, 15, comma, or parenthesis, I guess end parenthesis. It'll look like this on your screen on the app. And I get 99, almost a score of 100 really. So to get a homework pass, based on that inverse normal, 99.6, 99.7, or 100, depending how you round. I would round up, but 99.7 or 100. We'll just say rounds to 100. So you can use either empirical rule on 1 and 2, and then 3 through 8, you're either using normal CDF or inverse normal. As always, email me if you have any questions, and happy calculating.